Well, in math, we have what we call a Cartesian plane. So basically, I would say, with the help of Cartesian plane, now we are able to combine both algebra and geometry together. So in this video, we're going to briefly talk about the Cartesian plane. But yeah, I would say this video is going to be extremely short, but it's an extremely important one because it just lays down the important things you need to know about Cartesian planes. Okay, so in this case, let's start from part of the Cartesian plane in this case. So the first very most important thing is we have this like little center point. Like you can actually place your center point anywhere you want, but as long as you have a center point, then it should be good. Now, along this center point, you can just put a line over here in this case. In this case, I color it red, and let's call this the x-axis. But most of the time, when we want to draw them on a piece of paper or whatsoever, we draw them horizontally. So, yeah. Now, perpendicularly, we can have another line or an axis. In this case, it's the y-axis. So in this case, we have two axes. The x-axis, which is the horizontal one, and the y-axis, which is the vertical one. So yeah, they are perpendicular. Plus, one important thing about Cartesian plane is you will need to give a unit length in this case. Like for example, I define from here to there is a unit length of 1, and with that you can actually construct this whole plane. And then now we are ready to dive into some of the more of the details of the Cartesian plane. So what is in my hand is, well, you can call it a ball or whatsoever, but in here it's a point. So what can a point do on a Cartesian plane? Basically, the first thing we can do is figure it out. How can we describe where a point is? Like for example, if I just put a point over here, how are you going to describe the position of this point over here? So one way to do it is to tell us how many units across the x-axis, and then how many units across the y-axis. So in this case, oh boy, let me quickly go grab a pen. Alright, back with the pen. So now we can actually just give them numbers, so we know. Just quickly write it. This is 0, and then we can have 1, and then we can have 2, and then we have 3. And over here, it's almost the same thing. 1, 2, 3, and then 4. So over here, we can actually just describe this point as 3, 4. Not quite sure if it works, but yeah, over here we can actually describe it as x is 3, y is 4 in this case. So over here we described a point. Now here's the thing. If you have more points, let's say I put this one over here, and then you can actually see with enough points you can actually make a shape out of it. So yeah. So one important concept is a shape on the Cartesian plane is actually made out of many dots in this case. So yeah, that's one thing to keep in mind, because this concept is extremely important, and then we will keep on using this concept. A shape is made out of infinite numbers of points, but of course in Konnekt we only have 8 points. But mathematically we have infinite points for any shape we have on the plane. Well, unless it's a single point, then it's just a point, then yeah. Okay, so last time we also talked about functions, and turns out we can actually try to plot the relationship between the input and the output on the Cartesian plane and see how does a function behave. Let's say if we have the function f of x is 2x and then plus 1. So let's say this is the function that we want to plot. Then here's what we can do. Let's start off with the point where our x coordinate is 0 in this case, and then in this case we will let our y-axis be the output in this case. So when x is 0, plug that into the function, then we have oh no, my brain's not braining. 0 multiplied by 2, 0 minus 1, negative 1. There we go. So I know this point is over here. So when x is 0, our y is negative 1. One thing I forgot to mention is, by convention, up is positive, down is negative. For x, right is positive and left is negative. So yeah, that's a convention. Keep on moving on. So when x is 1, plug that into function, then we know y is positive 1. And then we can keep on doing this. Like when x is 2, we know y should be 3. Or is it? Yep, yes. Okay, we're right. And you can keep on doing the same thing again and again and again. And then with enough points, we can actually see that this kind of function, if a function looks like this, like some number of x plus or minus some number, you can actually see this, when this function is being plotted on a Cartesian plane with enough points, you might realize that this is actually a straight line. So yeah, so in this case, different functions give you different shapes. In this case, like this one gives you a straight line, and some of the functions or equations in this case gives you some other shapes. It can be a circle, it can be an ellipse, or whatever you can think of. So in this case, yeah. So yeah, just in case, like I said, this is an extremely short episode. However, that you can make on the Cartesian plane. And yep, of course we're going to cover the straight line as well. But yeah, that's for the next episode. So yeah, see you there.